Well, hello everybody and welcome again to another OpenShift Commons briefing. Today we have one of our NuoDB folks, Joe Leslie and Tom Gates here to talk about deploying their NuoDB database using their NuoDB Operator. And I'm going to let them introduce themselves and then there'll be live Q&A at the end. These are some of my favorite things to talk about, operators and the NuoDB stuff and all the work we're doing. So there'll be, I assume, a lively conversation at the end as well. So Joe, why don't you take it away and set the stage?
Great. Thanks so much, Diane, for the invite. Tom and I are glad to be here to present the NuoDB State of the World with our operator. And just some quick intros. So I'm Joe Leslie. I am the NuoDB product manager, and I cover all things OpenShift, container related, Kubernetes related, and basically our cloud native strategy. And with me today is Tom Gates. He is our lead and chief OpenShift and operator developer. Tom, won't you say hi?
Hello, everyone.
I threw Tom off. He was probably on mute. All right, great. Well, hey, let's go ahead and get started. Just gonna spend a moment here on our agenda so we all know sort of how we're going to spend this next hour. So I know many of you probably are not familiar with NuoDB or maybe have some familiarity. So I'm just going to spend 5 to 10 minutes talking a little bit about who NuoDB is, kind of what our mission is, what we're all about, and really some of the benefits of running NuoDB in an OpenShift cloud native environment. Most of the time we're going to spend in a demo. We're going to demonstrate some of our latest advancements with our NuoDB Go operator. Today we have a NuoDB Helm operator, which is published up on the OpenShift Operator Hub, so it's easily accessible for everyone who's running OpenShift 4 and greater. And we always encourage everyone to go ahead and give that a try. It's a good and fun experience. In fact, we're going to do that today. We're going to run through the same experience with the Go operator. And we're going to deploy a NuoDB database, then we're going to deploy NuoDB Insights, our visual workload monitoring tool. And we're going to start up a SQL application, much like our customers do, to run a SQL load against our database. And we're going to demonstrate a database scale out using OpenShift, as well as we're going to demonstrate how OpenShift and Kubernetes and NuoDB work together to orchestrate auto recovery. And then we'll have plenty of time for Q&A. Also, feel free to ask questions if you like during as we go. Also, that's fine. Diane, are the lines open, or will people be typing in the chat box?
People will be typing into the chat box, and we'll try and let you flow through your presentation and demos first. But if someone does a showstopper question in the chat, we'll pause you and make you answer it.
All good with that. Okay, great. Thanks, Diane. All right, so let's go ahead and get started. So we're just going to do, like I said, a brief introduction to NuoDB. NuoDB is a modern cloud native. We also describe ourselves as cloud agnostic. We do run up in all of the common clouds. We run on-prem as well, so you can run us in Amazon or Azure or Google, whichever you like. We are a distributed SQL database. So out there's no SQL and there's SQL databases. We are fiercely SQL, so we're like a traditional relational database system, much like an Oracle or a SQL Server, except we run really well in cloud native environments where more legacy databases don't run well there. We're all about high throughput transactions, and really what this slide tries to demonstrate is that NuoDB, we're set on delivering on all those cloud benefits that many customers would like to achieve, like scale and cloud agility and continuous availability. But at the same time, retain all of that investment in your enterprise SQL applications that so much has gone into. And so that would be retaining the ANSI SQL, ACID compliant transactions, any existing skills, of course, in database and SQL, and then retain all that business logic that has been invested in. So it's really the best of both worlds. It's move to the cloud, but retain that investment in the application layer. Okay. So some of the trends that we have, I just clicked too far. Some of the trends that we just wanted to share is we're seeing organizations increasingly move to the cloud. They realize the benefit of moving to the cloud, and we're seeing a large movement there. Likewise, many of us realize that Kubernetes is the de facto standard now when running containerized workloads in the cloud. And lastly, Red Hat's OpenShift product is just leading the market in container management platforms. And that's what we'll be demonstrating today, is NuoDB running in a Red Hat OpenShift environment. I also wanted to quickly share why we like operators. Today we're going to be demonstrating the NuoDB operator. Well, why do we like operators? Why are so many vendors building operators? Well, they're really easy to use and very accessible. They're easy to use in that you're deploying via a managed package, as opposed to something like where we used to edit YAML files and edit scripts and run them, and that was always error prone. Today now, operators are built to run tasks the same way every time. And I say, accessibility simply because now you can just pick and click, right? You just pick and click the application you want from Operator Hub, and you can literally deploy from catalog to cluster in under a minute. So it's a fantastic user experience when working with operators. Next, security reasons, right? Once a vendor publishes an operator to a marketplace, like Operator Hub, customers can be assured that they've been scanned for security vulnerabilities, they've been tested, verified, and they're ready for your use. So security is another benefit of operators. They also add operational support. Specifically, I'm referring to, like Ansible Playbook or Go type operators, where they automate beyond provisioning, and they allow vendors, like ourselves, to provide fully managed day 2 operational tasks, all from within the operator. And then, operators being a Kubernetes thing, it's kind of like a build once and deploy many. So it's portable code for vendors to run across Kubernetes distributions. So those are some of the main reasons why we like operators. This screenshot I've included, this is really what we're going to kind of demonstrate today during the demo, but this is NuoDB, the cloud native database, and towards the left is a more traditional way you might run a database in a cloud environment, where you see the software components are tightly coupled together, as opposed to the NuoDB architecture, where you see that the components are in separate bubbles. We have transaction engine layer and a storage manager layer engine, and those two layers scale independently. The transaction engine is running the SQL statements on behalf of the clients, while the storage managers are then making any DML statements, any insert, update, or delete statements durable to disk. So this is a good slide. It's a great one to screen capture if you like, and as well, these slides will be available after the presentation. So this is a good one that just shows the architecture a little bit. Okay. So with that, I'm just going to talk a little bit again about what we're going to see in the demo. We are going to install the NuoDB Go operator. Then we're going to deploy a NuoDB database, and we're going to deploy the NuoDB on-cluster Insights visual monitor. We'll talk more about that as we get there. And then we're going to go ahead and run some SQL applications, much like our customers do, and demonstrate some of the nice, cloud capabilities, like easy scale out and auto recovering after failure events. Okay, so I'll just go ahead and switch over now to our demo environment. Okay, and so what we're seeing here is on the left is an OpenShift 4 environment. This is the web UI. Hopefully many are familiar with this. And then over to the right is, I'll clear the screen. This is just a CLI screen where we're going to issue some commands to our operator, once it's running, to do certain things like give us a NuoDB database and so on. Now, as I mentioned, it's the Helm operator today that is up on Operator Hub. So why don't we go ahead and show off Operator Hub just a little bit. It's very easy to get to. I'm going to go ahead and show you, how you would deploy the NuoDB operator today. You go ahead and select Operator Hub. And I called it sort of this nice, click and pick type of interface, where you would go and find your tile or your application and say, oh, there it is, NuoDB operator. Go ahead and click on that, and then you would click install. Okay, and this would go ahead and install the operator, the Helm operator, into your OpenShift selected cluster. Here, we'll go ahead and pretend, right, we're going to do this. We're going to actually install the Go operator. But this is what I would do if I was going to install today's, right? I would go ahead and say, oh, well, I want to install it into this project, and then I would simply subscribe to it. And once you do that, you're about 60 seconds away from the operator running in this environment. Typically, I like to click over to the installed operators page, and it will show you as the operator is installing sort of the steps. And then once it's done, you would click on status and you would see your operator, okay? So like I said, that's a very automated step. Many of you have probably already done that with maybe some other products. Our Go operator is not yet up on Operator Hub. It will be in several weeks in time for the KubeCon event out in San Diego. Hopefully many of you are gonna go out there. We'd love to meet you at booth 53. Feel free to stop by for a more in-depth demo. But at that time, the Go operator will be up on Operator Hub, so it would be a completely automated experience. So what I'm going to do today, since it's not on Operator Hub, I'm going to deploy the Go operator using a little script. Okay, and all it's going to do is it's just going to create a whole bunch of Kubernetes objects to deploy the operator. And you can kind of see immediately off to the right, to the left, is the operator deploying. So I'm just going to make the screen a little bigger, and sure enough, we see the NuoDB operator, and it's already running one of one pods. Okay, so we now have an operator deployed, and it's that quick, right? It literally is from catalog to cluster, and in this case from CLI to cluster in less than a minute. Now, one of the things we like to show is how you can provision a custom database. When you start a database, there could be lots of different little memory or CPU type parameters that you may want to tweak or configure. So there is, I'm going to show you a NuoDB CR YAML file, and this just gives you an idea of some of the things that you would have control over. You can create a persistent store database or an ephemeral. We always recommend persistent. So in the event of any failure events, that you know that your storage is reliably there when a pod recovers. Insights. I mentioned Insights. Insights is our visual monitoring tool. You'll notice here I have it set as enabled true. I'm going to start 3 admin processes. Admins is what creates a domain suitable for running a NuoDB database logically across multiple zones, multiple hosts. So it's an important part of a distributed system. And then you can start to see all the other little details, right? Like storage sizes, what storage classes. I'm just going to be using the standard AWS Elastic Block Storage. I've decided to call my database DB and my users DBA, and my password is secret, so don't tell anyone. And you have a lot of control, right? Memory and number of counts of processes and so on. So before you start your database, you would just edit this file, right? And then that's how you would create a custom database. So I'm just going to run a little command here called give me a NuoDB database. And what it's going to do is it's going to start the database, but it's also going to start the Insights visual monitoring tool. Why? Because I said true here, right? So go ahead and start it. We want that in our demo because we want to visually be able to see resources as they're being used in our environment, as well as when the SQL app is running, what is the workload being generated. Okay, so we're going to start the visual monitoring tool as well as the little sample app. So go ahead and run that command, and you can see that the database just leaps right out of the operator. So I'm going to move this screen over a little bit more here. And so while it's basically bringing up the Insights monitoring tool, we'll explain a little bit about what we see here. So we see these three process types that sort of leaped out of the operator. We talked about them a little bit earlier. There's the admin, and you may recall we asked for 3 of them. So it's off starting those 3. It has 1 of 3 already started, so that's great. But we can see that the storage manager is already running 1 of 1 pods, and the transaction engine is also running 1 of 1 pods. So as long as you have 1 admin, 1 transaction engine, and 1 storage manager, you have a NuoDB database. It's fully up and running. It's not redundant yet, right? You still have a single process of each, but you would be able to issue SQL commands against this database. Okay. So it's also starting up the other processes, as I mentioned, and that's kind of what we see scrolling over here to the right. It's running through some check loops. So we see it starting now, the Insights server. So while it's doing that, I'm going to explain a little bit about Insights and what it's doing and what the options are. So with our monitoring tool, you can choose to either use our NuoDB hosted monitoring tool up in the AWR portal. It would be you sending your performance stats to our portal, and then we would give you a subscriber ID where you could then connect and see privately your monitoring data. However, with the Go operator, we have implemented what we call on-cluster insights. That means all of the visual monitoring can also be hosted within your OpenShift cluster. This is great because this allows you to fully manage your data. It's privately held within your cluster. Again, you're not connecting to any sort of remote or public cloud to go gather up your performance data. So that's what the on-cluster visual monitoring is all about. And it looks like it's pretty well started. You can see a whole bunch of components: Grafana, Kibana, and all these pieces that are there's servers that are starting. One way to check is if we go over to our Grafana interface and I refresh. There's our little Grafana bouncing ball. And we can see that we're now connecting. We don't have data yet, but we will. We actually haven't run much of the workload yet. And we are gathering data in 30-second intervals, but displaying in 10-second intervals. So pretty soon we're going to start to see some activity as I refresh the screen. And so, I can see over here to the right, it's now our startup process has fully completed. Again, all of that will be done via Operator Hub. Once we've published to the hub, it'll be a pick and click, and all this will happen. And then you will have the opportunity to create that custom database as I showed by editing the CR YAML file. Okay, so now that our database is up and running, and I can start to see now some workload is coming in. You can see over here, there's some little lines coming in. It's still very early as those Weisse ESB processes are starting up. That's our application. You can see more data coming into the screen. It's indicating that we have 1 transaction. I'm going to shrink this screen just a little bit so we can see a little more. So we can see we have 1 transaction engine, 1 storage manager, and a workload is starting up. If we look in the lower aggregate panel where we see aggregate transactions per second, we can see that we're starting to hit this database with a good amount of SQL. We're running approximately 4,000 SQL statements per second, okay, with this little SQL application that we're running. Okay, this will stabilize somewhere around 4,000 for this single app. Okay, but what we also want to demonstrate is how easy it would be to scale out a NuoDB database inside of OpenShift. If we look now at the screen, again, for the database, we have one transaction engine. Okay? And if I was to go find my application, okay, I could look under workloads and go to replication controllers. There it is, the Weisse ESB load. And we're only running one. So, we could pretend a little bit that maybe we're a bank, and this is a banking application. And we've just brought this banking application online for one department, but it's been running very successfully, and it's servicing, about 500 users. And now we're about to roll this application out to other departments within the bank, or we've acquired a new, subsidiary, and we're going to roll this application out to our subsidiary. Right? These are all common things that companies do. So what would that look like in an enterprise product like OpenShift running NuoDB? Well, if this is the application, we may just bring online two more, right? So I'm going to go ahead and click Edit Count, and I'm going to triple the SQL load to this NuoDB database. Okay. Now that's going to saturate that single lonely transaction engine that I have right now. But that's okay, because we're going to add more transaction engines to match this load. So I'm going to click Save. So we've just tripled our load as those start up. And if I move over to the deployments, I'll find my transaction engine, calling that it's running only one. We'll go ahead and edit the count and add two more. Okay. So we've just scaled up our database with a few clicks. Let's verify that. If I go back to status, we'll see that the transaction engine is now running 3 transaction engines, right? In fact, I could even click here, right? And it will show me all 3 of those transaction engines running. Okay. And now that we've started 2 more transaction engines, I'm feeling rather confident that when I go over to my system overview screen, I'm going to see the impact of first adding more applications. So I'm going to expect to see more SQL load, and then also NuoDB responding to that load by effectively processing more SQL statements per second. Okay. So again, we're capturing data in 30-second intervals, and these processes are now just starting up. In fact, you could start to see them here towards the left. We can see that initially we had just the one transaction engine outlined here in blue. And, by the way, we're tracking the memory usage for each pod, each container, for the TEs and the storage managers, as well as the CPU utilization for each. So NuoDB Insights is not only like a current active monitoring tool, but it's also a historical tool, right? Because you can go in here and you can select by interval, last hour, 3 hours, last day, and so on. And you can go back easily to view exactly what was happening on your database system at any given time. So with the introduction of the other colors, we see these other transaction engines coming online. So we had the first transaction engine. It was processing just over 3,000 transactions up to approximately 5,000. And now as I cursor over here, I have 3 active transaction engines all working in chorus, in unison here together to process more, right? And this lower panel indicates that. We see here that we were chugging along somewhere around 4,000 SQLs per second. At one transaction engine, we added 3 transaction engines, and with that increased load, we're now processing over 8,000 SQL statements per second on this cluster. And again, this is just a 5-node cluster running in AWS, running OpenShift 4.1. Okay, so it's literally that easy to scale out or increase database throughput to match an application workload. Right? We could also scale down too, right? Like if we were to take some of those applications offline, I could just as easily scale down my database and use less resources. Now this is really hard to do with any other legacy tool. Again, those tools, They don't scale out independently with the transaction and the storage layers separately. NuoDB makes it very easy to scale either independently. So we've scaled our transaction engines to 3. With the community edition, we do allow only 1, but we'd love to be able to work with you on a proof of concept and provide you our enterprise edition so you can also scale out the storage layer. When you scale out the storage layer, you're effectively creating multiple copies of your databases. Therefore, if you were to lose one of the storage managers, your database would continue to run. It would be your applications would not be impacted at all. In fact, we can start to demonstrate some of that capability now that we have 3 transaction engines, right? We have redundancy built into the system. If we go back to OpenShift, you'll recall here are those 3 transaction engines that are running. We could, to demonstrate how OpenShift and Kubernetes works together to orchestrate an environment. And if we recall, really, whenever we're running a system based on Kubernetes, we're always setting a desired state, right? And then Kubernetes, along with OpenShift, is going to enforce a desired state. So if we were to demonstrate a failure event, again, that's why so many customers want to move their workloads to the cloud, is if there is a failure, there are built-in systems to auto-correct, auto-recovery, so the applications run unimpeded, unimpacted. So we are redundant here, right? We have 3 transaction engines. Diane, could you do us a favor? Could you just choose one of these transaction engines to simulate a failure event? You go ahead and pick one, and we'll go ahead and kill that one, and we'll see how OpenShift is.
Kill the one on the bottom, the one that's
on the bottom. Okay.
LRZ. Yes.
Yeah. So sorry here for this K9R LZ. So we're going to simulate a failure event. Now, failure events are common, right? In fact, our software is built for failure events. We expect either hardware, software, or network failures to occur in the common world, which they do. So we're going to go ahead and delete this pod. Okay, so sorry, but there you go. We're going to delete it. Now, as soon as we delete it, OpenShift and Kubernetes are orchestrating together. You see this one terminating, but you see the one on the bottom here creating, and it's in fact already running. So in about 4 or 5 seconds, the whole system has identified the failure event, and it has replaced this transaction pod with a brand new one, MGCQF. Okay, well, that was pretty cool. That all could have happened in my sleep, right? I didn't have to be here for that to happen. There's no manual intervention to restart these pods. So if we go back to our visual monitoring tool, let's see what that might look like. Now, we know we had 3 transaction engines, and they were all processing about the same amount of transactions. So I would fully expect for that 3 or 4 seconds that our transaction per second would drop. And we're actually starting to see that now. I'm going to demonstrate this by choosing the last 5 minutes, because it will really help show how we were just chugging along at about 8,000 transactions per second, quite nicely, and then whack, right? We had this little failure event. So you see on the green line that the transactions per second drop just for a very brief moment, and the yellow line is indicating the NuoDB behavior, right? That we were at 3 transaction engines, and then we fell to just 2 for a brief period of time, and then look what's happening. We're fully recovering, right? In really just a blip of the system, we're seeing that the system self-healed, right? While one transaction engine was going down, the other one was coming up. If we look at some of the other panels, you can actually see that. If you follow where my cursor is, you'll see this little orange one here. You can see where it stopped, right? That's the one that Diane chose to kind of knock off, right? And then if we follow the colors, we'll see a brand new one. I can see it here. It's the green color one. right? Starting up. So for a brief moment in time, we just had the 2 running, right? And then here, now we have 3 running again, okay? So it's really a quite, nice, automated system and really built for enterprise applications, right? Many customers love all of the capabilities of NuoDB as far as running ANSI SQL and ACID transaction compliant and how easy it scales. But in the end, what they love to see is that this green line never went kaplunk to the bottom, right? That would be application impact. That's when somebody at a terminal would go, what happened? I was running some transactions or I'm seeing now a delay in my screen, right? Here, there's very little impact because no one's going to notice the difference between running 8,000 transactions and 5,000 transactions for about 3 or 4 seconds. Okay? So that's kind of a nice demonstration, so far of how we can, deploy the NuoDB operator, right? And today we showed it from the command line, and as I mentioned earlier, it'll be on Operator Hub soon. And then what we demonstrated is how you can create a custom database by editing some files, right? We did more NuoDB cr.yaml, and we saw all these nice little parameters that you can edit to build a custom database. And then what we did is we demonstrated how easy it was to scale our database, right? We added more applications, and then we added right here, right, 3 of 3 transaction engines to match that load. And then finally what we did is we chose to show the resiliency of the database by killing one of the transaction engines, simulating a failure event, and we saw how OpenShift and Kubernetes worked together to quickly heal the system. Now, again, I mentioned that we are using the Community Edition. The Community Edition allows for 3 transaction engines and 1 storage manager. So we could do the same thing if we were to deploy the Enterprise Edition. We could add a storage manager and then also kill one of those off. Likewise, with the admin layer, we have 3 admins, so we could go ahead and kill an admin and then also see that the applications run unimpacted. I think it's also interesting to, so far we have showed you how you can completely manage and monitor NuoDB from OpenShift. So far, no one has had the feel of learning a new database product, right? You haven't needed to manage NuoDB using NuoDB commands. Well, just for fun, I'm going to show you the NuoDB commands. Okay, if we connect to one of the admins, right, I'm going to connect to a terminal window, just so you can kind of get the feel of NuoDB, under the hood, and that there is a running domain and database processes. I'm going to run the nuocmd show domain command. Okay, and you'll see our little database. We know together, right, we were running 3 admins, right? We asked for 3 admins. So, so here they are. We see admin 0, 1, 1 and 2 running. They're all connected to the system. And then down below, we can see that we have the 1 storage manager. Hard for me to actually see my cursor with the black screen. 1 storage manager and the 3 transaction engines. Okay, and we can see that they're all being monitored and they're all in a running state. Okay, so there is a NuoDB management interface that you can connect to show and investigate certain things, but by and large, the whole system is designed to run from its hosted Kubernetes management tool, in this case, OpenShift. Okay? So we have seen a lot. I've been, chatting and talking through everything. Now is probably a good time to take a little pause and see if we have some questions. I was just showing the last 30 minutes. Go ahead.
And we do have a couple of questions. I'm going to unmute someone, Noel. And actually, you'll have to unmute yourself. There's a couple questions around storage. So go ahead, ask them.
Hey, hi, Diane. Hi, guys. I have two questions.
Hi, what is your name?
My name is Navonil.
Nice to meet you. Great. What is your question?
Nice to meet you, Joe. My first question would be, what are the persistent storage recommendations for NuoDB in production workloads? And my second question would be, is there any database backup on DR options while installing using operators?
Okay, great. Yeah, so as far as the storage, persistent storage options, yeah, when I was showing the file earlier, I was kind of showing how you can choose between persistent or ephemeral. We pretty much always go with persistent, as a database should always be viewed as a stateful application. We do support many options for persistent storage. And some of it depends on your application, right? If your application doesn't have a high I/O kind of write workload, then you could choose to do something, similar to maybe what I did. In your cloud provider, you could just use standard storage, right? In this case, I'm using Elastic Block Storage. I'm referencing it with a storage class called GP2, right? And if you were running in Google, you would change that to standard. And if you were using Azure, you'd use the Azure storage. But if you want to use some other storage components, you certainly can. We have tested and certified with several. For example, Portworx, OpenEBS, Linbit, some of the more common ones we have tested with. We have never found issues using these tools. I can make some recommendations with those products. They do like to, some of them by default will spin up a replica count equal to 3. That's really not necessary with NuoDB because our storage manager effectively is creating a copy of the database. Now here, we had just the one storage manager. But if we were running in an enterprise environment across multiple zones or regions, we would start up more storage managers. And that would create persistence across a geography. So I don't really need my Portworx or OpenShift to create multiple copies for me, right? For example, if I had 3 storage managers and I was running Portworx with replica equal to 3, I have 9 copies of my database. Do I really need 9 copies? Probably not, okay? So a lot of times what we do is when working with some of these high throughput third-party storage tools, we just set replica count equal to 1, and then we manage replicas through our storage managers. Okay. Now, as far as the DR component and backup and recovery, yes, we do support backup and recovery. We have YAML templates for backup and recovery, Helm charts for backup and recovery. We support full, incremental, and journal-based recovery methods. You could choose to run either in an active. We recommend that. Or an ActivePassive, depending on your kind of distance between remote locations. But active is great, right? Because you could throw storage managers live in each region, and if you lose one, your applications run unimpacted. You don't have to go through some, ActivePassive trying to bring up a passive node, which can always be, difficult, tenuous procedure. There's always some time associated with it. With NuoDB running across, clusters and nodes, if you lose any one of the processes, as long as you have redundancy in that process type, your applications will continue to run. Okay, so in other words, you don't necessarily have a DR event, right? In fact, in our documentation, you won't find disaster recovery because we use a different model. We tend to think of it as disaster avoidance. But if you do want to run an ActivePassive for any reasons, you certainly could do that and keep a live or frequently refreshed copy on a remote site, which you could then activate. Okay, so hopefully that covers both parts of your questions. Do you have any follow-ups there?
No, thanks, Joe. So I was wondering, the backup and recovery and the storage options you talked about is perfectly fine in a cloud environment, but when it comes to, on-premise deployments, I mean, is there any recommendations or, options for these type of scenarios just for on-premise?
Yeah, I mean, we recommend setting up a backup volume, right? So you're going to set up volumes typically for your admin layer, your storage layer, and then your backup layer. So and they could be of different speeds and feeds and so on. So yes, we would recommend kind of like a backup volume. And that's where you could then write your backups to. You would then schedule your backups through the NuoDB interface, the template and Helm chart model that we have, and then you're kind of good to go. You're keeping a regular copy of your database. Tom, is there anything that you would like to add about kind of the storage persistence or running the backups? Again, Tom is our kind of chief operator and Kubernetes developer, so he may also have some inputs to add there.
No, Joe, I think you've covered it pretty well. It's pretty much everything that I wanted to say. Okay,
great. And as I mentioned, the backup and recovery, it's we have Helm charts for that today. By KubeCon, we'll be at booth 53. Stop on by. We'll likely have our backup and recovery working from our operator. Again, the whole idea of the operator is when you're running the operator. If I just go back to that page, from the command line, you would send signals to the operator to basically do things. Right. And, what we demonstrated today really is a level 4 operator. If we look at the operator levels, right, level 1, provisioning, level 2, rolling upgrade, level 3, backup recovery, level 4 is workload metrics collection and analytics. So we basically demonstrated our level 4 operator with this Insights visual monitoring tool. And, again, this will all be available for you to either play with. If you would like to today, you can play with this now. If we, just jumping back quickly to our slide presentation, the last slide was, I wanted to leave a link where you can go and try and play with this yourself. To try the NuoDB operator yourself, just go out to our NuoDB GitHub. There's a NuoDB Golang operator page. Or operator page. The Golang will be there shortly publicly. And give it a try yourself. Like I said, the Helm operator is there either via Operator Hub or via these directions on the GitHub. Diane, do we have any other questions?
I think that I think he covered most of the questions that were there in the chat, and I think he actually did an amazing job covering out all the features and functionality, and I'm really looking forward to seeing the Golang operator up there in Operator Hub. I can't think of any other questions to actually ask you because you did such a wonderful job there,
Awesome.
and I'm looking forward to seeing this in action sometime soon, and seeing if we can get perhaps one of your customers who is using it to talk about a little bit more in depth about how what their use cases are for it. So that would be wonderful. And
Absolutely.
I'm
that
really
could even be a follow-up.
Yeah, I think that would be a great one to do, and as well. We will be doing a lot of operator framework talks in the coming months in the operator framework SIG. So if people want to know a little bit more, maybe what we might do is get Tom to come and talk about any of the nuances or lessons that he learned about building operators and getting to level 4, because that is actually a very awesome thing to go beyond the one step beyond simply installing and deploying your offering or a database or whatever the service is, to really take advantage of the operator framework, and you guys have done so very nicely. So thank you for that extra effort, and I'm really looking forward to seeing it in Operator Hub and seeing it in action soon.
You bet. That'd probably be about 2 or 3 weeks away. And Diane, Tom and I will both look for you on the Monday Day Zero event at KubeCon. So you and I have already met, of course. But, I don't think you've met Tom. So Tom and I are all signed up to be out on the boat. So we're looking forward to that. And I would encourage others. These Day Zero, I've attended these before. These are awesome events. I would encourage anyone to come and learn what's new and what's happening. Meet the folks of Red Hat. It's a great day, and Diane, we'll be looking forward to being out there again.
Yeah, so what Joe is referring to, if you don't know, is we're having an OpenShift Commons gathering on November 18th, which at KubeCon is considered Day Zero. And we have rented the largest yacht I could find with a 540-person auditorium on it. It will be tied up to the dock in San Diego, right near the convention center where KubeCon is. And we are going to navigate through a whole lot of very interesting OpenShift use cases. Lots of the new operators will be showcased, and there'll be lots of great opportunities to network with your peers, to meet Tom and Joe in person, as well as if you're coming to KubeCon, you can meet them at their booth somewhere at KubeCon. They'll be easy to find on the vendor floor, and this is, it's a great opportunity, the gatherings, to really get to know and meet your peers and make those connections. So I'd encourage everybody to join us in San Diego for the OpenShift Commons gathering. And join us on the boat. It's going to be fun.
We'll see you there.
All right. Well, thank you all for taking the time today to join us. And thank you, Joe and Tom, for putting this together. And as I said, we'll be uploading this to our YouTube channel. And I will link in the slides, and you could find the video links and everything on OpenShift.com, the blog, as a post probably tomorrow afternoon. And we will make sure we schedule a follow-up soon so we can get more details and learn more about what you're doing. So take care, guys, and we will let you get to your meeting on time.
Great. Thank you, Diane. Thank you all for joining.
Take care. Bye-bye.
Bye-bye.